Svelte has been more successful than we ever imagined. So successful that Vercel now employs 3 people, including me, to work on it full-time. We're backed by dozens of maintainers who work on it in their spare time, and we're surrounded by a thriving and super friendly community. We're very thankful for where we are today. With this backing and confidence into the future, it was time to reassess Svelte as a whole. Instead of looking at incremental improvements, we thought holistically about the strengths and weaknesses that make up Svelte and to see, okay, what can we do better here? And we based our thinking on our own experiences and those of the community. At the same time, it was very clear for us from the start that any change we're making should be incrementally adoptable. So in an ideal world, you bump your Svelte version to 5 in your package.json, run the install script, and then everything continues to work without changing a single line of code. And so we began somewhere mid of last year that we started brainstorming the wildest things. We explicitly didn't constrain ourselves at the start to have an open mind as much as possible. And we thought about very, very different things, went down many different roads, built little proof of concepts to see what things are actually feasible. And we did a lot of things. We thought about going all in on labeled syntax, much like you have the $: today, and expand on that. We thought about getting even more implicit by somehow magically inferring the intent based on static analysis so that you need even less syntax to begin with. We also thought about making our own superset of the JavaScript and invent new keywords so that you can express what things are reactive. By doing this, we quickly discovered along the way the things that we actually care about and the constraints we want to give ourselves then when designing this new API. So what we noticed is that we want an API that is usable inside and outside of Svelte components, so that you don't have this kind of developer experience cliff you have today where everything is great at the top level of Svelte components, but as soon as you extract logic out, you somehow have to turn it into something completely different to keep it reactive, like using a store. At the same time, we wanted to make it easier for tooling to support us, which meant labels or custom syntax was basically out of the question because like TypeScript doesn't play ball with that. But most importantly, we didn't want to lose the vibe that you have when writing Svelte. This is something we discovered while brainstorming, that this is an important trait of Svelte, which we at the start of this year wrote down as part of the tenets, the guiding principles when designing new APIs. And so in the end, with these constraints and ideas and goals we turned up with a solution that is far more conventional than what we originally thought it's going to look like, which is great because it means you don't have to change as drastically. You can reuse existing JS knowledge and the existing ecosystem. So it's overall a really nice outcome, we think. The outcome concretely is the most important one is the runes API, the thing which you're now seeing at the screen. So basically, instead of doing let something equal something else, you now have these functions starting with a $sign that are not really functions because you don't import them from anywhere. These are more like compiler instructions to the Svelte compiler to know, oh, this variable is now reactive state. So whenever it is updated, something else that depends on it should also update. And this is the runes API, which we'll look into more detail right away. Apart from that, we have 2 more features. One is snippets, which is a new way of re-rendering small bits of UI which you don't want to extract into a new component right away, and which is also conveniently replacing the existing somewhat confusing slots API we have today. Lastly, we have event attributes, which replace our existing event system that we have. And I think the best way to get to know these new features is to look at an example app where we have the old syntax and then gradually convert towards what it's going to look like in Svelte 5. So let's dive in. Okay, this is our little example app. It's a to-do app, very simple. We can add new to-dos to a list. We can toggle them on and off. We at bottom see how many to-dos there are left. And on the top right, we have a little clock that's ticking and updating every second. Implementation-wise, this is split into 4 different files to showcase the various APIs and see how they look like in the new world. We have app.svelte, which is our entry point. We have list.svelte, which is a generic list component that renders items and then passes these item information back up to the parent component so that it can render these items however it likes using the slot API in this case. Then we have our input component, which wraps around the regular input, taking away some of the implementation details there, making it easier to interact with the input. Most notably, whenever we press enter, it will dispatch an enter event and then clear out the value of the input. Lastly, we have our clock file, which is a regular JS file in which we use a writable to contain the current value of the clock, and every second, we updated it here. We're doing this outside of the Svelte file to showcase, okay, we have to use a writable in Svelte 4 in this case. And using it looks like this. So we're importing clock here from that file, and then we prepend a $sign in front of it, which means we subscribe to the value, and automatically Svelte will re-render whenever that value changes. As you can see, this is running in the Svelte 5 preview REPL, but it's using Svelte 4 syntax, and everything works as expected. So this is our hope that most apps won't have to change a single line of code. They can just upgrade to Svelte 5 and keep using the old syntax and then gradually opt in to the new world. Let's have a look under the hood to see what this compiles down to. And we can see that if you have ever looked at the Svelte 4 code, it's quite a bit different from before, and notably it's also quite readable. So our to-dos translates to a mutable source. Here our open to-dos translates to a prefect. Here at the top we have different templates that make up the UI. Then we walk these nodes. Then we have a text effect here, which basically means whenever the clock value updates, rerun this. Then we're using our input component, which is just a function under the hood. We pass it a placeholder and we pass it events. Same goes for the list item, and we pass in children and slots to get the things done. And what you maybe also see between the lines, that this code is much more runtime based. So previously, Svelte 4 was leaning heavily on generating code for creation, mounting, updating, deleting things, which quickly became like the per component cost was substantially higher than it is now, which meant if you have dozens of components, your app might actually get a bit bigger than you imagine. And that's no longer the case here with Svelte 5, because the runtime based output allows us to have much smaller component size, much more output size per component, making the resulting bundle of Svelte apps that even have a few components already smaller than the bundle was in Svelte 4. And if you're reading between the lines, you may also see mutable source, etc. Like the naming hints at something. Yes, we're using signals under the hood. We're not exposing signals as a first-class primitive, but we're using signals under the hood because it's a great way to model this kind of reactivity. Okay, so with that out of the way, let's transform the given code towards using the new APIs. And we start with using runes. We transform the code to using runes. So to-dos is obviously state, so we're going to surround it with the $state rune. That way we are telling Svelte, hey, this variable is state, and so react to it by re-rendering whenever it changes. And now Svelte is telling us that the $: syntax, which we previously used to mark a derived value, in this case open to-dos, that's no longer allowed in runes mode. So certain syntax like the $: or export let, etc. is no longer allowed in runes mode. That means we cannot mix and match legacy and runes mode within one component. We can, however, mix and match runes components with legacy components and vice versa. So in that case, we're going to transform this to using derived, which is another rune, which basically tells you, okay, whenever to-dos, which is state, as we said here, changes, update open to-dos. So it's a derived value. And in the case of Svelte, that's all we have to do to transform to using runes here. And as you can see, it continues to work. Svelte is now a new file, a runes mode in runes mode, while it's using components that are still in using the old syntax. So it works side by side. Okay, so we've converted app.svelte. Now let's look at a list.svelte. Here we have export let items. Export let means this items is a property of the list, so you can pass items as a property to list. In runes mode, this looks a bit different. It looks like this. So we have the $props rune, and whatever we destructure from it are the properties that the component expects. So this is all we have to do here. And next up is our input.svelte component. Here we also have a property named placeholder. We are going to transform that to using $props as well. And now it tells us you cannot use $rest props in runes mode anymore. And what $rest props did in Svelte 4 is that it basically contains all the properties you haven't explicitly defined at the top using export let. So that was a way to say spread along everything else that a component user might want to pass along into the component. And if that looks a bit weird to you, it's because it probably is. With Svelte 5 and using runes, this is much more straightforward. We're just going to declare a rest property. We're going to use a rest prop in here. So this is a standard destructuring syntax whenever using like destructuring an object, and we can just tell the $rest props concept using the spread syntax here and then passing it along, resulting in the same result that everything that is passed into the input component, for example, here is passed along onto the input element. Okay, and that's that. Finally, we have the writable inside our JS file. We're using a writable here because we're inside a JS file. So in Svelte 4, we can only use this magic let is reactive syntax at the top level of components, but we cannot use it outside. So to use that outside, we regularly, we probably use something like the writable instead. With runes, we no longer have to do that. Runes can be used everywhere. They can be used at the top level of components. They can be used inside functions. You can even use them in JS files. Although note that it needs to be .svelte.js or .svelte.ts files for it to work, so that the compiler knows, oh, this is a .svelte.something file. I'll look into this. This prevents the compiler looking at all your files, which may slow down compilation, but it also makes it more visible for you as the author of the library or app or whatever. Inside here are probably Svelte specific things. So we're going to use $state inside here as well, which means we no longer have to learn the writable API if we're new to Svelte. We might get around if learning that for a long time. We can reuse our existing knowledge about runes outside of Svelte components too, and stay within the happy path, so to speak. So we adjusted that, and now we also no longer need to subscribe to it because it's no longer a store, it's just a regular variable. So we're going to remove the $ prefix, and the clock is continuing to tick. Okay, so that's about it for converting runes. Now let's look at snippets next, which are a replacement for slots. Slots are used inside the list component. So the list component is a generic component, so to speak, which takes in an array of items and then renders each item, but it passes the information about the item along with the index back up to the component that uses it, so that the component that uses it can define how the UI should look like. In this case, it uses the default slot. Down here, it uses a named slot. So in this case, the slot name is empty. That means if items doesn't have a length, then we show the empty slot instead, in which case we show nothing to do yet here. So that's how we are going to use a named slot. We're just doing the slot equals empty and pass in whatever we want. For the default slot, we don't have to give it a slot name, so this is implicitly passed in as the list item. So ASD is this button. And now the confusion begins, because how do we get the item value in that parent component again? It's through this let::item syntax and let::index, and that way we tell it, okay, this is the property we're passing back up, and then we're using it inside here. And now we could also rename item to be more understandable, so we can tell it equals to do. So we could use, instead of item done, we could use to do dot done. And now it's like, is item the original name, or is to do the original name? And it all just becomes very confusing. And it also looks like we could use the to do name inside the empty slot, because it looks like it's in scope. But doing that means we get a runtime error, because actually no, that's not the case, because the default slot is rendered when we have a list of items, but the empty slot is rendered when we have no items to render yet. And so item, the to-do variable or the item variable is just not defined in this scope. So it's all very confusing and hard to wrap your head around. So this API needed an overhaul. And to do that, we have snippets. Let's first look at snippets in general. So a snippet looks like this. We're doing #snippet. Then we're giving it a name, open brace, close brace. This looks a bit like a function definition. And then inside we can use some HTML. And we're going to make this just a hello. And this by itself doesn't do anything yet. So it's just like in there, and we need to render the snippet so that it's actually visible. So we're doing render greet, and that way it's now showing up, and we can do that multiple times. So wherever we do add render, we can reuse the defined snippet here and greet. We can also pass an argument inside, so we could have a name here and tell it, okay, I'm passing Simon as name in here, and then it says, hello, Simon. So this is the basic API of snippets, which is, I think, really easy to grok. And most importantly, we can also use that for replacing slots. So how does that look like? Let's get rid of this, name the snippet row. We're getting item and index from it. And then we're just passing in the button here. So like this, name this back to that. And so basically we have now declared a snippet for our rows each. And now we will also want to declare a snippet for the empty case, which we're going to do next. So let's delete that. And boom. And now we can pass these snippets as props into our list component just by referencing their name, row and empty. And on the other side, to use these snippets, they are just now part of props, so they're row and empty, and we're just going to render them. So we're going to render row and pass it the item and the index. And the same for the named slot. If it's there, if it should be rendered, then we just render empty. So everything continues to work as before. Now it might feel a bit disconnected to have row and empty at the top and then pass it as props. That like it doesn't feel like these things belong together. So we have a bit of syntactic sugar for this. So if we move snippet inside the component here, we're basically, this is the equivalent code to what we had before. This implicitly passes row and empty as properties into the list component. And so that way we can also use snippets for the slot feature and using a much more streamlined, understandable API in doing so. Okay, that's it for snippets. And now finally we'll look at event attributes. So for this, we're going to look into the input.svelte file. Here we use create event dispatcher. This is a function. You have to call at component initialization time, which returns a dispatch function, which you then invoke with a certain payload, and you can then listen to it on the other side at the component usage by doing on:\enter, and then you pass in a callback function that is invoked whenever this enter event is dispatched. You have the thing that is dispatched is not the payload directly, rather it's a custom event, so you need to do .detail on the callback because that contains the payload. The thing itself is the whole custom element. So it's all a bit indirect, it's a bit much to set up, so yeah, we'd like to avoid that. Listening to DOM events looks similar in Svelte 4. You have on:, and then the event name. So in this case, on:\keyup. And what this and we also have this on:\keyup without a handler. And that means we want to forward the event. So in case app.svelte ever wants to listen to the keyup event, we now forward it. But what that means is if we could listen to the key up event, but if we wanted to listen to the click event, so for some reason maybe we want to listen to that, that doesn't work because it's not explicitly forwarded. We would have to add it here to work. So what that means in Svelte 4 is that you're, as a component library author most likely, are forwarding all these props just in case, and as a component user, if the component you're using doesn't forward that event and you don't have access to changes, then you're just out of luck. And so this is all a bit like unideal, and we can change this for the better. In Svelte 5, you can just use event attributes and callback properties. So by doing so, by using event attributes, we just delete the colon, and that way we're listening to the key up event. It's on, and then the event name all lowercase, and that way we're listening to it. We also no longer need the event forwarding because we can forward events through properties. So by spreading along ... props into the input, we're implicitly also spreading along any event attributes that we pass in. So I no longer need to explicitly find all the events that I'm interested in. If I'm just passing along all the props, then I can also pass along the onClick event attribute, and then it works just as expected. So that way you can get rid of the colon for event attributes, and we can also get rid of the create event dispatcher thing. So we're just going to delete that, and instead we're going to create a onEnter event, and we're going to call it if it's available and pass it the payload that we're interested in. And that way we invoke onEnter here. No, so we have to change this to onEnter. It's just a callback property at this point, so we pass the add_to_do function, which is then invoked whenever onEnter is called here. And because it's now passing through the input value as a payload directly instead of passing a custom event, which we then need to call .detail on, we can also simplify this to just using the text directly. And I should get rid of the onClick event. And that way, everything continues to work as expected. Okay, that's it for the demo. We've seen the new APIs of Svelte 5, runes, snippets, and event attributes, and we've seen the benefits that come along with it. First, we have glitch-free, consistent reactivity, which we get thanks to shifting more of the reactivity into the runtime. This in itself fixes a whole class of issues. It fixes somewhere between 30 to 50 issues on the GitHub tracker. Second, we no longer have this kind of developer experience cliff that we had before, where you're happy at the top level of a Svelte component, but once you have to refactor the stuff out of it, you have to resort to much more imperative things such as stores. This is no longer the case because you can use runes everywhere and that way stay in happy Svelte land. Third, and this is my personal experience, the result is much more readable. Now I can see at a glance what certain things of my code is supposed to be doing. I see a $state and immediately know, oh, this is something reactive to which the UI reacts. And the overall thing is now easier to learn. Svelte 5 is even easier to learn than before because it's less concepts to learn now. Previously, you had things like export let or the $:, which all looked a bit different and did different things. Now it's one syntactic concept that is used for all the things that Svelte needs for its reactivity, runes, which are all functions starting with a $, which also makes it much more much easier to approach Svelte in a new code base and seeing, okay, I don't know what this $state is about. I'm just going to hover over it and then immediately get a bit of documentation inside the hover info. This just wasn't possible before. Snippets are similar because they are just outright simpler to learn compared to slots, especially if you get into the more involved or more advanced use cases of slots. At the same time, they enable new features that just weren't possible before. Now you can re-render little bits of your UI without having to extract them out into a component directly. That's great. Third are event attributes, which again are similar because it's less concepts to learn now. Previously, we had this different thing, the event system, which you had to learn how to use it, what the API is. Now everything's just properties and attributes. You just pass onClick as an attribute to a DOM element. You just pass onClick as a callback property to a component. It's less concepts to learn that way. At the same time, again, this makes things possible that just weren't possible before. Previously, if you wanted to forward all events of a DOM element to a parent component, that just wasn't possible before, but now it is, thanks to events just being properties. Overall, we're very happy with how Svelte 5 turns out to be. We're currently in beta phase. We'll hope to have a release candidate out soon. When it's done, we think that Svelte is going to be more scalable, more consistent, all the while being easier to learn than before. We're very excited about the future of Svelte, and we hope you are too. Thank you.
Thanks so much for that presentation, Simon. That was really good. I'm going to say one of the things I love about Svelte is that as somebody who's done JavaScript for a long time, I always feel like okay, I know I can understand Svelte. Like I don't have to wrap my head around a whole different way of doing things. Svelte feels like just JavaScript to me, and that is great, you know. So anyway, great stuff. I love seeing what's coming in Svelte 5. I have a handful of questions already lined up from the audience. But folks, if you have more questions, please be sure to add them to the Q&A module. So first up, first question is from Derek. How much smaller is the Svelte 5 compiled output compared to before?
Percentage wise, I don't have the percentage out of the top of my head. I mean, it also varies depending on what the component does, but I'd say it's roughly half the size per component. So
Right.
it scales much better. The runtime will be a tiny bit higher. So there is maybe a point, like if you have a very simple Hello World component, then Svelte 5 might be a tiny bit bigger than Svelte 4. But as soon as you have like two components or more, it's already going to be smaller than today.
Okay. That sounds like a significant improvement.
Yeah.
So does that affect like overall, do you find like it performs better? Is it build quicker? I mean, does it help any of these other things or it's just more of the bundle size?
It's also much faster because we are using a different reactivity model now. I touched briefly on this in the talk, but probably not enough. So we're using signals under the hood now, and they allow for you to tell each DOM node exactly, okay, you depend on these things, and you should only re-render yourself when one of these dependencies have an update. In this case, cascades also through to other things like derivations or effects that you have in your user code. So everything is much more fine-grained, so to say. Whereas in Svelte 4, if you changed something at the top level of a component, at the top level of your component tree, and it only affected something deep down in that component, you would still have to go through all the intermediate components, like calling through. And that's no longer the case with signals because they basically the component tree is skipped, so to say, and signals the thing, the end goal directly and tells it, hey, you need to update. And so for that, it's much faster runtime wise. it will be also faster to hydrate. So the time between you server render the whole app, and then you load the JavaScript, and then from there on, there's a process called hydration, which then makes everything so that from there on you can like click a button and there's actually some JavaScript that reacts to that. And during hydration, state is preserved in a way so that it's like picked up where the server left off. That one's also faster. And finally, the build time itself will probably also be a bit faster, just because the compiler, like we've rewritten it from the ground up, and like we've simplified a few things here and there, and the overall like number of loops it has to do, etc., is smaller. So it should also be a bit faster to compile. But I don't have any numbers on that.
Awesome. That sounds great. Okay, so we've got from Stefan. He says, "I've seen some work on image optimization component sorry, excuse me, on an image optimization component for SvelteKit. Wondering how is that going, and will it be tied to Vercel?"
So there's some ongoing work of an image optimization runtime component. That's like there are two parts to this. One is the static image optimization, which is the one that can happen at build time, where you use a tool like Sharp, which takes an image at build time and then scales it to whatever you want. And for that, we already have a preview working. It's, I think, at svelte.js/enhanced image. I believe that's the package. You can use it independently of SvelteKit, and it's build time based, so it's like not dependent on any underlying platform, so not connected to Vercel in any way. What we don't have yet is something similar for runtime image optimization. Basically, you give the app an URL, and then it will call an image optimization service like Cloudinary or Vercel or whatever to optimize your images on the fly. And that one we don't have a built-in first-class solution yet for. We've explored different APIs. We didn't find something where we're quite happy yet with. It's also that we're a bit spread thin because we're working on Svelte 5 at the moment, so not much work happening in that area now. But we will have something there in the coming months, and that also won't be tied to Vercel. Like, of course, you can use Vercel's image optimization through that, but it won't be in a way that you're locked out from using other image optimization providers.
Great. That's awesome. Okay, so Brian asks, is there an MPX migrate tool for making these changes or highlighting code migration opportunities? And has that been done in the past?
So we've done code migrations in the past. There's an npm package svelte-migrate, which you can use, for example, to migrate from SvelteKit 1 to 2. So it will bump your package JSON, do some code mods where that's possible, etc. And we are striving for having a similar thing for the Svelte 4 to 5 conversion. We're not yet sure yet what exactly we can migrate automatically. Some things will be pretty simple. Other things will be harder. So like more involved slot things will probably be a bit tough to figure out statically. But yeah, we'll definitely have something there to auto migrate, especially with regards to non-runes mode to runes mode. So like if you have export let something today, that will then automatically turn into the let something equals $props rune. So these migrate code mods should be pretty easy. And yeah, we'll have to see how that goes. It's also that there may be some very, very slight differences in semantics when you migrate to runes. So it's like not, you can just do it on your whole code base and then push to production without a second look. So yeah, but there will definitely be migration tools to help you with that. So you
Okay,
don't have to do it
great.
yourself.
I'm curious, is there like this is something people can try today in some kind of pre-release form, or is this something that's still not yet released? And I mean, not the migration tool, just Svelte 5. Can you try it
Yeah,
out today?
you can try that today. So it's Svelte at Next. There you will get the Svelte 5 preview releases. Um, you can also get them through if you do npm create Svelte at latest, then you'll get the Svelte kit setup CLI, and then in the last step there's an option to try out Svelte 5 experimentally. So you can also do that through that. So yeah, it's available on npm. You can play around with it, or you can of course go to the website svelte 5-preview.vercel.app, where you can try this out right in your browser.
Awesome. Excuse me. Okay, JT asks, how should we think about this in connection with SvelteKit? So are these changes going to be in SvelteKit soon, or is this something that will come later?
So we'll definitely, before we'll release 5.0, we'll definitely make sure that it properly works with SvelteKit, and it will be in a way that it won't be a major version at first. So what we probably will do is like first make it compatible so that you can use SvelteKit with Svelte 5 without changing anything in SvelteKit. And then we'll probably in a minor release some variants of like today you have this giant page store which contains everything, the URL, the current data, the page state, etc. And like it's a coarse-grained object. So if anything in there updates, the whole thing updates, and so everyone that listens to that, regardless of whether or not the thing you're interested in has actually changed, you're still notified. And we'll probably have a like fine-grained runes version of that available so that you can still use the page store, but it won't be a store anymore. Rather, it will be like a rune object with fine-grained reactivity on it. And stuff like that is on our roadmap to bring to SvelteKit, and then we'll see from there on what other benefits we get from integrating Svelte 5 more deeply.
Nice. I really like and appreciate the approach you all have taken, which is like adding these improvements, but you don't, you can incrementally adopt them, even move to Svelte 5 and start migrating the pieces. So I
Yeah,
think that makes developers' lives so much easier than having to like do some massive migration project.
yeah, totally.
So
That's not like feasible at this point. I feel like we can't allow ourselves that. Like it's a bit like jumping from Svelte 2 to Svelte 3, and there was like no auto migration path to that. Um, Svelte 4 to 5 is not that big of a jump, but not having something for auto migration or not having it backwards compatible would, yeah, that would many people would really suffer. And especially if you're depending on a library and that library hasn't updated to Svelte 5 yet, and then you would be stuck, and that would really be really bad. So yeah, we're trying our best here to stay as backwards
yeah.
compatible as possible.